All right, let's dive right into this explainer. Today, we're unpacking something literally mind-bending. We're going to explore how one of the absolute most abstract theories in modern physics might actually be the ultimate recipe for reality itself. We're looking at Stephen Wolfram's physics project. And honestly, the implications here are just absolutely fascinating. So imagine stripping away all the crazy complexity of reality for a second. The galaxies, the planets, the completely intricate laws of gravity and quantum mechanics. What if everything we know and experience is really just a basic computational rule applied over and over again? What if the universe is, at its absolute core, just a simple code? Stephen Wolfram actually spent like 50 years chasing this fundamental theory of physics. And for the longest time, everyone in the scientific community just assumed that any foundational theory of the universe would inevitably have to be this incredibly complicated, tangled mess of equations. But he realized it doesn't have to be complicated to generate incredible richness. As he put it, the result is unexpected, surprising, and much more beautiful than he ever imagined. Just look at this comparison, because it brilliantly illustrates the whole idea. On one side, you've got this tiny, super basic, structureless rule. It's basically just a simple transformation of abstract elements. But on the other side, a massive, sprawling, universe-level graph generated solely by repeating that exact same tiny rule over and over. From ultimate simplicity comes immense, universe-level complexity. So the crucial takeaway here is that the entire universe might literally run on this basic three-step recipe. It's kind of like universe.exe. Step 1, find a relation between abstract elements. Step 2, apply a simple transformation rule to them. And step 3, repeat this zillions of times. This whole process operates at a foundational level, completely underneath space and time as we know them. Physics, as we experience it, is really just what emerges from this process. Section 1, Space is a network. Let's look at how this builds the very fabric of reality. Check out how applying this single rule progressively builds up a mesh. Progressing down from the top, it starts with just a few abstract connections between dots, right? But as the rule applies over and over again, the mesh becomes so incredibly fine and dense that it looks exactly like a continuous recognizable three-dimensional surface. Think about water for a second. It feels totally smooth and continuous to us. But underneath, it's really just a bunch of discrete molecules bouncing around. Wolfram's model says the universe works exactly the same way. It's a massive network of discrete, abstract nodes that only appear continuous at our human scale. You, me, the device you're watching this on right now, we're all just patterns in a giant, ever-updating web of abstract relations. Now, if you just tweak that initial code even a tiny bit, the network grows into a whole zoo of wildly different topological shapes, from flat planes to twisted loops or even branching trees. This completely proves that space itself isn't some pre-existing static backdrop. It's an emergent property created dynamically by the underlying rule. Section 2, Time as a computation. Having built space, we now need to understand how time flows through this network. In this setup, time isn't just a dimension you can slide back and forth in like space. Actually, scratch that. It's not a dimension at all in the traditional sense. Time is simply the inexorable, progressive application of those rules. It creates a chain of causal relationships, meaning what absolutely must happen before something else can happen. This flow of events, trickling downwards through the network, is the actual passage of time. Okay, here's a term you really need to remember: causal invariance. It is absolutely crucial because it's basically the glue holding our reality together. It means that even if the network updates in different sequences or branches out into different possible computational paths, all those paths ultimately merge back together to create a single, consistent history. It literally doesn't matter what order you apply the rules in, the causal relationships end up exactly the same. Take a look at this massive web. It shows causal invariance in action for a really simple string sorting algorithm. You can see it branching out into dozens of intermediate steps, representing different possible paths of history. But look at the very bottom. They all perfectly converge into a single result. Even though an observer inside the system might experience entirely different paths of history, the objective reality converges perfectly. Section 3, Relativity, Gravity, and Mass. Now we step up to the macro scale and watch emergent physics take over. The crazy thing here? Special relativity just emerges absolutely automatically from that concept of causal invariance we just talked about.
Because the causal graph stays perfectly consistent no matter how you slice it or what order the updates happen in, observers moving at entirely different speeds will always experience the exact same physical laws. The speed limit of information propagating through this graph naturally gives us the speed of light. No extra math required.
And what about energy? Well, this was a huge, mind-bending light bulb moment for Wolfram's team. They realized energy isn't some fundamental physical substance. It's actually the flux of causal edges, essentially the sheer volume of information updating across the network. Put simply, more computational activity equals more energy. Then you have mass. You can think of it kind of like a computational traffic jam. Mass is basically activity that just reuses the exact same network elements over and over again rather than spreading outward. It's this localized, persistent, repetitive activity. Literally, it is information stuck in time. So where does gravity fit into all this? Well, when matter exists, when you have that localized mass we just discussed, it adds extra causal edges to the system. This effectively slows down the generation of space in that specific area, which causes space to curve inward around the mass. And when you calculate the math of this curvature in the hypergraph, it flawlessly reproduces Einstein's equations for general relativity. It is just breathtaking to see that fall right out of simple code. Section 4, the quantum universe. Now we're zooming out to the extremes, from black holes to elementary particles. In this model, black holes aren't just super dense stars. They are literal event horizons, where the causal network physically snaps and breaks off into separate, disconnected pieces. Meanwhile, particles, like electrons, are basically just locally stable knots or lumps of space. The model even predicts these things called oligons, which are much lighter, stable relic particles from the early universe that barely interact with anything. And honestly, they could perfectly explain the massive mystery of dark matter. I'm quantum mechanics? In this framework, it's not just possible, it is absolutely inevitable. Since a single rule can apply in multiple different ways at any given moment, the universe is essentially computing all possible histories in parallel. It builds a multi-way graph of branching paths that perfectly mirrors the bizarre superpositioned reality of quantum mechanics. Bringing the whole shebang together, this magnificent visual summary just unites everything we've been talking about. You can see how one single foundational rule at the top left seamlessly weaves together a spatial hypergraph, causal networks, general relativity, and quantum multi-way branches. It elegantly scales all the way up from basic abstract elements to the ultimate hypergraph of our reality. So, we now have this incredibly beautiful framework for how the universe works. We can clearly see how complex physical laws emerge from ultra-simple operations. But of course, the ultimate question, and the one I really want to leave you pondering today, is this. Out of millions of possible rules, out of the infinite expanse of the entire computational universe, which exact line of code is computing our reality right now?